Right, the next caller on the line is Joyce. Hello, Joyce, are you there? Joyce, hello?
Hello?
Hi there, welcome to Maths 911.
Hello? Okay, fine.
All right, Joyce.
Hello?
Joyce, listen to me. The volume on your TV set is extremely high and it's interfering with me being able to listen to what you're saying. So can you turn it down,
hello?
please? Right, can you hear me now?
Hello? I'm fine.
Okay, we seem to be having a crossed line, and I'm going to start the question without Joyce. Joyce, won't you watch the solution on the screen? Right, question that Joyce had was very, very interesting because it connects two branches of mathematics together. It has a little bit of finance, and then we need to utilize a mathematical tool called a logarithm in order to be able to answer the question. Now, for those of you who are writing the new syllabus, there are a number of you watching that are still rewriting the grade 12 higher grade syllabus or standard grade from last year. You will also be having this question in your paper, but for the current syllabus, the subject assessment guidelines on logs is very, very clear that the old questions on logarithms are out. The reason we are doing logarithms is simply to have a tool to help us with the financial maths, and that's exactly how I'm going to tackle this question. Right, I think that the cross lines have been sorted out, and I think that Joyce is with us. Hello, Joyce.
Hello?
Hi, can you hear me?
Fine.
Fantastic. Welcome to the show.
Hello?
Where are you calling from, Joyce? Okay, I don't think Joyce can hear us. I'm going to carry on without Joyce, unfortunately. Right, Joyce's question was as follows. We have a motor vehicle, and that motor vehicle is going to decrease in value, as we know, and we want to know how long will it take that vehicle to decrease in value so that it will be a quarter of its original value. So we want to know how long it takes for the motor vehicle to be a quarter of its original value. And that is not sufficient for us to be able to know how long, because we also need to know the rate that we're going to depreciate or decrease the value of the motor vehicle. So the rate that we were given is that the car will depreciate at 20% per annum. Right. So pretty straightforward financial problem. We want the car to be a quarter of its original value. So we have the formula that connects our future value with our present value, and the rate of depreciation multiplied by n, which is your number of periods. So the future value we know is a quarter of the original. So if the original was p, then the future value will be a quarter of what that original value was. So let's say the original value is 100, for example, then a quarter of 100 would be what we would be requiring for the future value. So a quarter of p is equal to p multiplied by 1 minus the rate that we are given is 21 over 100 to the power of n. And our job is to try and find what that value of n is. So we're trying to solve what n is. And PV is really not necessary at all, because if you look carefully at this equation, you have, if I want to solve for that portion over here, I'm going to divide by PV on either side. So I'm going to get a quarter of PV divided by PV, which will equal to 1 minus 21 over 100, would be 100 minus 21, so it's 79 over 100, which is just 0.79. We're raising that to the power of n. That cancels out, so we're left with the equation 1 quarter equals 0.79 to the power of n. So far, all we've done is two things. We've translated the mathematics in the English into mathematics by taking the formula for the financial maths in terms of present value and future value. We've substituted the rate in, and now we land up with this equation: 1/4 equals 0.79 to the power of n. How do we solve an equation, or how do we solve for an exponent when we have the base and we have the result? And this is where the logarithms come in handy. The logarithms look as follows. If I have, and I just want to do a little note on the side here, if I have a equals b to the power of x, and I want to write that in logarithmic form, it looks like as follows. X will equal to the log of a base b. Since we're working with base b, and that's the exponent, the log is a synonym for the exponent, so the exponent x will equal to the log of the result a to the base b. B remains a base. So that's all we're going to do. We're going to rewrite that into log form. And if we look at it carefully, we have that 0.79 is our base, n is our exponent, so we're going to take the log of 1/4 base 0.79. So here we go. Just change my color. Log of 1/4 base 0.79 will equal to n. Where do I get this from? Because we had earlier that 1/4 was equal to 0.79 to the power of n. I can interchange between log form and exponential form, where 0.79 is the base in exponential form, it's the base in log form, and n is my exponent, and I want the log of 1/4. But the calculator still can't do that. So we need to just change into a format that is useful for us, and that will be the change of law base, which says that that is the same as log of 1/4 divided by log of 0.79, and that will be equal to n. And that is our change of base law. It's one of the log laws that we get used to, that it's the same thing as changing to base 10 of log of that result over the log of the base. That will be exactly the same. So that would be our log law. And then finally, if we just use our calculator and we take log of 1/4 and we divide that by the log of 0.79, we get 5.88. And since our rate was per annum, we get 5.88 years. Now what I'd like to look at is, does that mean that it will take 5 years and 8 months to depreciate to 1/4 of its value? What does this 0.8 actually mean? That means 8/10. So it's not 8 months, but it actually means 8/10 of the year, which is actually 12 months. And 8/10 of 12 would just be 96/10, which is 96/10, which would be 9.6. So it would actually convert to 5 years and 9 months with a couple of days, and then you could calculate how many days. So for our purposes, we will just say 9 years, and it will take a little bit longer than 9 months. We'll actually need the extra month, so 5 years and 10 months. Your car will have depreciated to 1/4 of its value. That's how long it takes. Right, hopefully that has connected the two branches of maths, the financial and the logarithms. Very useful to find out the number of time periods required for either an investment or depreciation to occur.